So we've been talking about solids of revolution where you revolve around the x-axis. We've talked about revolving around the y-axis. We've talked about things with a hole and things without a hole. So what we're going to talk about today is when you revolve around things that aren't actually the x-end or the y-axis, but what they are like x equals 4, y equals 2. Technically, you can revolve around oblique lines like y equals x, but we're not going to do that. So lucky for you. But really what we're going to keep using for today is this volume of a washer formula, where basically you have the integral, where you have the outer radius squared, and you have the inner radius squared, and then you find their difference and multiply by pi. So we're going to maintain that same relationship, except now we're going to modify our expressions for the outer and inner radius based on the function and the axis of rotation. So if we come down here to this first example here, we have curves here that are known to be y equals radical x equals 1, and this other guy. So this is going to be the y equals radical x line. This is going to be x equals 1, and then the curve here is going to be y equals e to the negative x. And part A wants us to find the volume of the solid created when r is revolved around the line y equals negative 2. All right, so y equals negative 2 would be down here. This is obviously not drawn to scale, but y equals negative 2 would be right down here. So if I spin r, this region right here, around the line y equals negative 2, I end up getting something a little wonky that looks like that, with the middle being right here on y equals negative 2. So if I spin it, it has a hole in it. And I know that my hole right here, this area right here, is going to be the middle of my washer. And whenever we talk about the volume of something with a hole in it, I always reference your outer radius and your inner radius. So our outer radius goes from the line y equals negative 2 all the way up to the curve y equals the square root of x. Well, how long is that segment? Well, that segment would be the distance from the x-axis to y equals root x, and the distance from the x-axis to 2, which all together becomes radical x plus 2. So that's going to be my outer radius. And then my inner radius would be the distance from y equals negative 2 to the graph of y equals e to the negative x. And that's just going to be e to the negative x plus 2. So in essence, for both of these radii, we really just add 2 to the function. So the volume of the solid created is going to be the integral from, I don't know my values yet, from some x value here out to x equals 1 of pi times the outer radius squared, the square root of x plus 2, minus our inner radius squared, e to the negative x plus 2. And then trust me on this, if you went through and found out where these two things intersect, this point right here is going to have an x value of 0.426. So this is going to be 0.426 here. Throw it into your calculator, you should get an answer of 3.292. Now what just happened? Let me erase and kind of re-explain what just happened here, because a lot of stuff happened all at once. To find the volume of a solid, you do pi times the outer radius squared minus the inner radius squared, and then you do the integral. Well, if I'm revolving around y equals negative 2, my outer radius is this red line right here. The length of that red line would be top minus bottom. The top curve being the square root of x, the bottom curve being negative 2. And if I do the square root of x minus negative 2, that's how I got the square root of x plus 2. Then we did the same thing for my inner radius right here, e to the negative x minus negative 2, which became e to the negative x plus 2. All right, moving forward. B, find the volume of the solid created when r is revolved around y equals 3. All right, so let me get rid of all this. Y equals 3 is now above. Again, this is not drawn to scale. So let's say y equals 3 is up here. Now, when I spin it around y equals 3, my outer radius goes from 3 to e to the negative x. Well, to find the length of that line, I'm going to do top minus bottom again, and I'm going to get 3 minus e to the negative x. And then for my inner radius, it's going to go from 3 to square root of x, so 3 minus radical x. So my volume is going to be pi times the outer radius squared minus 3 minus the inner radius squared. And then we still have that 0.426 value up to 1. Outer radius squared minus inner radius squared, 2.867. All right, so take a look at that, rewind it if you kind of missed anything, but long story short, to find the outer and inner radius, you end up subtracting your axis of rotation and your curve, but you always make sure you do top minus bottom. Top in this case was 3, bottom was e to the negative x, 3 minus e to the negative x. All right, moving on to number 2. T is the region enclosed by that. Okay, well, I should have been a little bit more specific. I am not referring, I'm sorry, it says W is the region. I am not referring to the region above. That's why I named it W. So W is this new region that I'm just making up, enclosed by y equals x and y equals x squared. So let me sketch it here. Here's y equals x. Here's y equals x squared. This shaded part would be W. Here's y equals x. Here's y equals x squared. And we're going to revolve it around stuff. So revolving around the y-axis, that's one that you should already know how to do. These intersect at 1 on the x-axis and 1 on the y-axis. So if I revolve it around the y-axis, I'm going to have pi from 0 to 1. Y-axis means I want to be in terms of y, so dy. My outer radius from the y-axis is going to go from the y-axis to the parabola. And in our case, that parabola needs to be written in terms of y, so that would be radical y. And my inner radius is from the y-axis to the line, which is y equals x, also known as x equals y. So pi times that integral, which is going to give me 0.524 if I round. That should be review, nothing new there. Now if I want to revolve around x equals negative 3, that distance now, I'm going to erase this and start from scratch. If I revolve around x equals negative 3, I'm going to have something that looks very much like the y-axis because it's vertical. So x equals negative 3 is right here. Again, not drawn to scale. This is a sketch. And I'm revolving this around that region right there. Oh, that was not a very good line to draw here. In any case, it's going to be kind of bowl-shaped like that, kind of curve out. It's going to be another washer, okay? Except now the center of my washer is this line x equals negative 3. So to find my outer radius, I'm going to go from x equals negative 3 out to x equals the square root of y. Well, the length of this horizontal line right here is going to be whatever this x value is minus x equals negative 3, so the length of this purple segment is going to be the square root of y minus negative 3, also known as the square root of y plus 3. It's just like what we did before, except now I'm dealing with a vertical axis. So I'm going to have pi times, now this is a vertical line, so it acts like the y-axis, so I need to be in terms of y for a dy. And my outer radius is going to be the square root of y plus 3. And my inner radius is going to go from x equals negative 3 over to the line x equals y. So this is going to be y plus 3 squared. Outer radius squared minus inner radius squared. Now, the boundaries, if you'll notice, are still 0 and 1. Your boundaries only have to do with the boundary of the region, not the boundary of the volume. So you can revolve around anything you want. These bounds are still going to be 0 and 1 no matter what. The reason we are in terms of y is because we're revolving around a vertical line. So vertical axis of rotation, means in terms of y. So make sure you know that from now on. And then last but not least, I should probably give you an answer for that before we move on. 3.665 is going to be your answer there. All right, let me erase this and start from scratch again. So if we come down here, very last one, around x equals 4. So here's the two curves again. I'm going to take that region. I'm going to spin it around x equals 4, which is to the right. So the length of my outer radius goes from 4 back to the line x equals y. So this distance is going to be 4 minus y. Notice I'm still doing right minus left. Above I did right minus left, but above the square root of y was on the right and negative 3 was on the left. Down here, 4 is on the right and the equation x equals y is on the left, hence 4 minus y. My inner radius goes from 4 to the curve, to the parabola. So that's going to be this purple inner radius is going to be 4 minus radical y. So then my volume is going to be pi 0 to 1 outer radius 4 minus y squared minus inner radius 4 minus root y squared. Throw that into your calculator and you get 3.665. Again, they are similar but not exactly the same value, just so you know. And there are my three values. Okay, so before we flip over the page, you need to know everything is still the same from the way we used to do it. When we do our volume, it's going to be pi times the integral of the outer radius squared minus the inner radius squared. However, when we go to take the outer radius and the inner radius, we have to find the difference of the axis of rotation and the curve. Okay? Difference of the axis of rotation and the curve. And when you find that difference, you're either going to do top minus bottom if you're in terms of x, or if you're in terms of y, you're going to do right minus left. All right, now you can turn the page. So if we turn the page, if you're feeling pretty good, feel free to pause the video here and give a couple of these a shot, and then unpause it and see what I'm doing. If you're still feeling trouble, watch me go through each one and kind of learn as you go. So we have this S and R region that we've actually seen before, and I'm very quickly just going to give you some values here so that I can keep using them. I'm going to call this A, I'm going to call that B, I'm going to call this value right here C, and down toward the bottom here, A, I'm going to identify as 0.902 and more. I would let my calculator calculate that and then store it. B is the cube root of 2, which again I'd let my calculator store. And C is 1.265, which again calculator would have stored. So there's A, B, and C. When I use those letters, those are the values that go with it. So if I want to revolve for part A, S around the line y equals negative 3, I'm going to think about where y equals negative 3 is, and it's down here below the graph. So my outer radius would go from the top line of S down to negative 3. The top line of S is the equation 2 minus x cubed, and the bottom line of S is y equals tan x. I'm revolving around a horizontal line, which looks like the x-axis, so I'm going to be in terms of x. S has a bounded region from 0 to A, and now I just need outer radius squared minus inner radius squared. My outer radius goes from 2 minus x cubed to y equals negative 3. So that's going to be 2 minus x cubed minus a negative 3, which is really a plus 3. My inner radius goes from y equals tan x to negative 3. So this is going to be tan x plus 3. Put it in your calculator. Get a solution, 30.207 for that one. All right, so if I get rid of these, I don't want to recognize it, I want to get rid of it. Get rid of this. I just want to move these out of the way here. There we go. So if we move on to that second one, and we look if it's above or below the graph, my apologies for all this deleting here. If I take a look at that second one to see if it's above or below the graph, I have y equals 10. Well, y equals 10 is obviously above the graph here. So y equals 10 would be up there. My outer radius, I'm going to be dx, because y equals 10 is like an x-axis. It's a horizontal line. So my outer radius is going to go from 10 down to y equals tan x. So 10 minus tan x, not plus, it's going to be a minus, pardon me, minus my inner radius, which is again going to start at 10 and then go down to 2 minus x cubed. Notice my parentheses there, 10 minus the quantity. So I have top minus bottom for the outer radius, top minus bottom for the inner radius. Throw it into the calculator, 64.587. Moving on. R now is revolved around x equals negative 2. X equals negative 2 is a vertical line. That means we're in terms of y. So for R, I need to make sure I'm in terms of y. And let's see, if I come back up and think about R, R is right here. I'm spinning around x equals negative 2, which is to the left. So my outer radius goes from x equals negative 2 to this line right here, which would be x equals, let's see, it would be the cube root of 2 minus y if I solve for x, so it's in terms of y. So my outer radius, right minus left, would be the cube root of 2 minus y minus negative 2, which is going to be plus 2. And then my inner radius is going to be y equals tan x, which is x equals inverse tan y. And if I do right minus left, I'm going to have inverse tan y plus 2. My y bounds for region R would go from 0 to c. And if you type that into your calculator, 12.653 and more. R is revolved around x equals 5. Again, this is vertical, so I want to be in terms of y. So if I spin around x equals 5 now is on the right. It's over here. So my outer radius goes from 5 to the tangent curve, and then from 5 to the cube root function there. So my outer radius for part D, I'm going to have pi, the integral from 0 to 3, 5 minus inverse tan y, minus 5 minus the cube root of 2 minus y, dy. Outer radius squared minus inner radius squared, 19.424. All right, part E, R is revolved around R is revolved around the line y equals negative 7. All right, I'm going to sketch this down here so I don't have to keep bouncing back and forth. But if I look at R is this like triangular region like that, kind of looks like a shark fin. Ah, sharks, here, look, doo-doo-doo-doo. I'm having fun. So I have that shark. Sorry, I had to have fun for a second. I've got my little shark fin. I'm going to spin it around the line y equals negative 7, which is down here. And if I do that, y equals negative 7 is like an x-axis. I want to be in terms of x. But I'm noticing that when I spin that around y equals negative 7, R needs to get separated into 2 separate regions. So I need 2 separate integrals. My first integral is going to be pi times, let's see, 0 to, we called that a. Pi times the integral from 0 to a of this curve right here, which is the tan x curve. So I'm going to have my outer radius from tan x to negative 7 is going to be tan x plus 7 squared. And then my inner radius just goes from negative 7 to the x-axis. Well, that's just 7 all the time. And then for my second integral, I'm going to take the integral from a to b, and my outer radius here is going to be that cubic, 2 minus x cubed minus negative 7. And then again, my inner radius is still just 7. So I have two separate integrals because r technically has two separate regions when I spin it around something that's a horizontal line. So you type all of that into your calculator, 10.421. And last but not least, r is revolved around y equals 8. Y equals 8 would be above, much the same thing that we did in part E. I'm going to have pi. I'm going to need two separate integrals. My integrals are still going to have the same boundaries, 0 to a and a to b. Still going to be in terms of x because it's a horizontal line. It's just now my outer radius goes from y equals 8 to the x-axis, so that's just 8. And then from 8 to the tangent, 8 minus tan x. On the other side of r, on the other side of this red line, I'm going to go from 8 to the x-axis again, so that's just 8. And from 8 to the cubic function, 8 minus 2 minus x cubed. Plug it all into your calculator, you get 10.971. And that is revolving around horizontal and vertical lines. Long story short, everything's still the same. Outer radius squared minus inner radius squared. But now to get to the outer and the inner radius, you are finding the difference of the axis of rotation and the curves themselves. So come ready to work. And I think we should be all set. Have a great day.